Hey guys, how's it going? My name's Daniel, aka HashLips, and today I'm going to be starting on the NFT contract. If you've not seen the previous videos, I basically just explained what we will be doing and go into some concepts of what we will be using. But today we're actually going to be starting on the smart contract. Now, firstly, what we're going to be doing is go to remix.ethereum.org and start a new workspace. We're going to call this maybe the NFT_game workspace, so we can keep everything nice and neat. The next thing that we can do is we do not need any of these files, so we can actually delete them and delete. Okay. Next, what we can say is new file, and this time let's call it something. Now we work with lips, so I'm going to create a lip token. Okay, so I'm going to say lip token.sol, and we're going to have that there. Lastly, this is a step that I'm going to take while I'm doing this tutorial, and this is just to have a reference back to the smart contract that I've created for the game, so I don't have to move around screens. So you don't have to do this step, you can just follow along. I'm just going to do this. So I'm going to say this is lip token, maybe old, or ref for reference, not old because it's pretty cool. I'm going to paste everything in here, and here you can see there I've got my smart contract. Okay, now before we get started by looking into all these things and what it does, I am going to write all this contract code with you guys. Now, the first thing that we want to do is, like I said, in our contract, how we start off with the lip token is we're going to put these two lines. Firstly, the license and then the pragma. Let's make sure that on the compiler did select the right compiling version. Next, what we want to do is actually have the start of our contract. So we will go and say contract. We're going to call this the lip token contract, and we're going to give it our brackets. Then we can actually start by coding it. But now remember what I said. We need to follow the ERC 721 standard. So if we actually go back, let's just close this off for a while. If we go back to our OpenZeppelin contract, we can see that here is a full-fledged contract, and you already know these two lines, and you see that this contract even imports other contracts, but here it is. And this is the ES keyword that we just learned about, and then going on, this is what it inherits from. Now we want to make use of the ERC contract itself, so we want to inherit from this one. Now this is, seeing that this is the whole contract, we can import this from Github, and this we import from OpenZeppelin contract. They have a bunch of contracts and a bunch of conventions that we can follow, but we'll use this as our reference. You can see that if I go back to my other one, to the remix one, you can see that in the in the reference contract, when we mention the reference, you can see that I already have imported these ones. But the reason why I just import them via @ is because I use them in Truffle. And Truffle then we import it into the framework, but it looks like Solidity also, Remix also imports these automatically for us now. But I'm going to do it a little bit of the old school way because it might not import for you and then you might get stuck. So what we want to do is, first things first, is import. So we want to import the ERC 721 contract from OpenZeppelin. How do we get that? Let's switch back to OpenZeppelin, and we're going to go to the URL. We're going to copy that. We're going to move back to our IDE and just say import this from this address. So this will actually go and import the contract right off GitHub, and we will have access to ERC 721. Now, this is very cool and very great. Now, the next thing we can do is say, well, our lip token is going to be basically ERC 721. There's a few other contracts that we also want to implement and add here. So what we are going to do is we're going to have another import statement, and this time we're going to be importing a ownable contract. What is an ownable contract? Well, it's a contract that actually allows you to say, I am the owner of this and I can do special things. So if we go a bit back on the OpenZeppelin implementation and we go to contracts, we can go to access. And here down in access, you can see there's an ownable smart contract. It's a very small smart contract, but it basically has a bunch of stuff that we can use. So we also want to make use of that. So let's switch back to our IDE and also import that. We want to make sure that we also are using the ownable. So like I said, you can inherit from multiple contracts. So in here we can say, well, this is also ownable. All right, so now we've got a lib token, which is ERC and ownable. Now I just want to quickly, briefly explain something small here. I'm going to, for a brief second, take this out. Going to the deploy contract section, and I'm going to select the lib token. There it is. We'll make sure it's from the right contract and deploy it. When we look here at the bottom, what we deployed is there's nothing in there, right? There's really nothing in there. And now when we put these two back, you will see that we get more functionality. We actually get all the functionality of ERC 721 and ownable. I hope that is now made clear. I'm going to show you now when we deploy it, but there's something else that we need to implement for the ERC 721 interface, something that is very needed because it instantiates it, and that is a constructor. So to explain what a constructor is, we can just look at the reference contract for now. A constructor is basically this small piece of code. A constructor is a function in essence, and it's the first function that will run in a smart contract. Okay, so basically what this says in here is you give it the constructor keyword, you say string memory underscore name, and then string memory underscore symbol, and then what we do is we pass it to the ERC 721 constructor. Because if you go ahead and you look at actually what's behind the scenes of ERC 721, it itself has a constructor and it requires a name and a symbol. So that's why we put this constructor here, because we actually want to give values to the underlying constructor, which is laying in ERC 721. Because we're not making use of it in this contract, we have to give it to that one so that it actually can instantiate properly. Okay. The thing with this memory after the string is whenever you have, I think it is a struct or an array, value type or string, you have to add a memory when you pass it in the parameters. If you don't do that, then this is a type of storage mechanism. Solidity won't know how to handle that string or struct, and then it might give you errors. So just go and do that like this. Later we'll get into the details. Like I said, it's not a beginner course, but this is what we start off our contract with. Now that we have this, like I said, we're going to deploy this just to make sure everything works. So the next time, remember, this was our smart contract. It was empty before, but now that it's ERC 721 and ownable, if we deploy this, we actually need to give it two parameters, which is the name. So let's just do that. Let's just say this is going to be the lib token, and we're going to give it a symbol. Now you realize I typed in a comma and then I can add the symbol. But let's do it a bit differently. Let's expand these options so you can actually see what we're typing in for the parameters. So like I said, we're going to say this is the lib token, and a symbol is just a shorthand version. So LPT, I don't know, LPT, that's fine. We're going to say transact, and it went through successfully. And then when we open our contract, you can see it has all these functions. And again, remember when I showed you guys in the previous tutorial about the ERC 721 standard, where we had all these functions that said a NFT needs to be able to transfer, approve, bloody blah, it goes on, right? It needs all these functionalities. So now when we go back to our Solidity contract over here, we can see indeed we have all these functions that we can do. We have transfer from, we've got all these things. We also have all the calls. By the way, the blue ones are all the call functions, and the orange ones are functions that you can execute. And there's also a red button, which is when you need to pay for something. But just to keep this short, this is how it works. And off the bat, guys, this will work. we just need to implement a minting function. And after we've done that, we've basically created our NFT. So up next, what we'll do is we'll continue with this contract and put in the bare minimums for an NFT. This NFT can actually be deployed and create NFTs, and it will show up on OpenSea. So let's get down to that and let's create the bare NFT contract. So the only thing now that we want to do to complete that little minting function or our minting contract for this NFT is basically we're going to create a minting function. So we can now just say function, and let's call it something like mint my NFT, right? Mint my NFT. We're going to give it brackets over there, and also we need to give it public to just make sure that we can publicly interact with this function over here. Now, to make this function a bit more secure, because if you think about it, if it's just public, everyone out there that can interact with a smart contract can basically call this and just mint things. So to make it a bit more secure, we've added the ownable smart contract, remember, and this ownable smart contract has something called a modifier. Now, modifiers are pretty cool. If we look at the ownable smart contract, we have modifiers down here, which we have a modifier only owner. Now, if we take this only owner modifier and add it to the end of our function, that basically adds extra logic. And basically how it works is it's going to run through this line. It's going to require that this is the owner, basically aka the contract, the guy who actually created the contract. And then once this function passes, once this require statement passes, then only it will run every code, every line of code that's in our function. So let's run back to the remix and actually add it there. So we're just going to say only owner. And that basically makes it secure enough to say only the owner can call this function. And we'll show this in a little bit. Next, what we want to do is we actually want to kick off the minting functionality. In order to do that, we can look at the ERC 721 contract and we can see what is required. So if we go back there to this contract, we can see that there is something that we need to implement way down here, which is something called mint, right? There's a mint function, but you also have the safe mint. Now, I prefer using the safe mint, so I'm going to be using that one. So let's go back, and all we have to do is we can say, well, use the safe mint, like so, and we're going to call it. Now you can see this is showing us an error because it needs to have arguments. So jumping back to there, you can see it needs an address 2 and an integer, which is a token ID. Now, how do we get those two things? Well, in Remix, it's pretty easy. What we can do on Solidity, you can technically, if you reference message, so sender, message.sender, this will be the first argument, and message.sender basically gives you the address of the contract that called this function. But we don't want that. We actually might need to mint it to someone else. So what we can do is up here we can say, well, let's use a type address and let's say 2, and then also we're going to put the 2 in there. Basically what this does is it says, okay, so when you mint a function, you need to tell us who this NFT is for, and then it will go in there. The last function that we need is a number, right? So we need to maybe add like a number like 20 to say what is the index or what is the identifier of this NFT that you're going to be minting. So we can't really just put 20 in there. That's hard coding it, and that's not going to work for us. So what we will need is an integer here at the top. So we can say UN256, and let's just call it maybe lip token, or actually let's just make it counter. But I want to do this all in caps because this I want to increment. So counter is going to start off at 0, and maybe we don't want that. Maybe we want to start off our NFTs all on 1. So the first NFT will be 1, and then next one 2, 3, 4, 5, 6. You can go up like that. So maybe we can just assign 1 there from the start. So what we want to do is we actually want to put counter in there, and then right after the safe mint happened, we can say counter plus which is the same as what you would say is equal to counter plus 1. Okay, it's just a shorter syntax. So what we're going to do is say counter plus plus. This increments the counter, so it's going to do a mint to an address. It's going to increment the count, and then the next time this function runs, this counter should be 2, and it will mint again. Okay, so this is our little smart contract which you're going to deploy now and actually test out. We just want to test it out, make sure we can run through the functionalities that it has. So the first thing that we can do is, I want you to notice that there's an account section over there where we can have a drop down with a bunch of accounts. The first account here, the Ethereum address that you see here, is basically the account that we have deployed this contract from. That's why it's 99 and these all are 100. Let's just, for the time being, select the top one where we're going to deploy this from. In our deployment contract, we're going to make sure that we've selected the contract that we want to deploy. And here we're going to fill in the name again. This time I'm just going to do lip and lip for the symbol. We're going to deploy this. I've deployed it now just before this. So you can open the contract then below here and you'll see all the functionality like before. Something that is new now is this mint my NFT, which you can see there is an extra function. Now, if we just click on it, you can see that there's an error, and the error is because there's invalid arguments. We need an address. So we need the wallet address to be in here to know who do we want to mint this NFT to, who do we want to give this NFT to. So seeing that we are the owner, we have to actually call this function while being on this address. But let's just switch briefly and copy the other wallet's address. So I'm going to click on this little symbol and switch back to the owner. Next, what I'm going to do is right click there and paste the address and then click mint. Now you can see everything went well. It actually minted an NFT for this address. I'm going to click this function again because I want to mint 2 NFTs, so to show you some of the other functionality of the calls. Now that we've mint this NFT, we have all these call functions which people can query outside of the blockchain to see details of the smart contract. In the balance of function, we can right click and paste and the address that we used to send these NFTs to, and we can query the balance. And we can see that this address contains 2 NFTs. And we have a bunch of other calls as well. We've got approved and all these things. We're not going to go through in detail, but we can query a few things here off the bat. We can query the name, which is the name lip, right, which we gave it when we launched the contract. We can see who the owner is, and this is the first contract over there, which is the owner. And we can also see owner of. Now, this is an interesting function. We can actually give it the ID of an NFT that we've made and see who's the owner of. If we give it an ID that it does not exist yet, like 3, we can say owner of and it will fail. Also, any of the other numbers would fail. But if we give it a 1 or a 2, because remember we've minted 2 NFTs, and we say owner of, it will actually give us the owner's address. And then lastly, this token URI is something we'll get into later, but if you query it, it basically should give you back a string of metadata so that OpenSea and all those other marketplaces can make use of your images. We can also query the symbol, which is just LIP. Now those are mostly the call functions that you can have a look through. And then up here for all the other ones, you can do cool things like transfer the NFTs and give it addresses to transfer from and so on. But all we care about is the mint my NFT function, because here is where we're going to be experimenting by minting on the blockchain game items. So the next step that we need to do is actually think of a way how we're going to mint more than just IDs, because our NFTs that we're going to be creating are not normal NFTs, which are just based upon images sitting on a URL and IDs. Our NFTs are actually going to have health and rarities and all these things. So in the next episode, what I'm going to be showing you is how to set up a struct where we can actually define how a game item looks. And then once we've defined it, we can mint a game item. Stick around and I'll show you how to do that.